All right, so we're gonna finish up chapter 7 with this video today. We're gonna talk about it's pretty short, so I'll just going to go over the info and then I'll go over one example with you, and then I'm also going to assign the chapter 7 lab as well. So this one's called percent yield, and percent yield is quite simple concept actually. So what we've been doing with our stoichiometry calculations. So determining the limiting reagent, and then once we use the mass of the limiting reagent, we can predict how much of a particular product we're going to make. That prediction is what we call the theoretical yield. That's how much we should get. If everything was ideal and everything was perfect, that's how much we would get. So it doesn't matter what the calculation is, what the numbers are. That's the theoretical yield is when we do our stoichiometry, what we've been practicing, questions out of our textbook. Now, in reality, we rarely get that amount, right? There's lots of different reasons why what we get after we do the experiment is not the same. So when we go and do a chemical reaction, we actually do it for real, the amount of the product or the amount, whatever that we're looking for that we get is called the actual yield. Okay? Now the actual yield is almost always a little lower than, sometimes quite a bit lower than 100%. So the way we calculate the percentage yield is we take the actual yield, what we actually got when we did it, divided by the theoretical yield, what we should have got if everything was perfect, and then we multiply by 100%. So one of the things we just common sense, or not common sense, but what we need to know in terms of relating it back to everyday life in the chemistry world is, well, why don't we get 100%? So there's a few different things. One of the reasons we wouldn't is called the nature of the reaction. So when we make ammonia, so we put nitrogen gas and hydrogen gas together and we produce ammonia. As soon as that ammonia is produced, a few of those particular molecules simultaneously start decomposing back. So what happens is that not all of the nitrogen and hydrogen gas combined to form ammonia stays as ammonia, some of it goes back. So that product we make is actually a little bit less than what we were predicting. Now, chemists have come up with, through multiple experiments, to find out what the ideal temperature and pressure is to get that max. We always want to get the maximum yield. So we want to go on, do things under conditions that will give us the highest amount. That way we're not wasting what could be very expensive reactants. Okay, so the nature of the reaction is one. The experimental procedure, how we do the experiment, can be one as well. So this is one of the things that if we were doing labs in the lab, it'd be nice if you could have done them this year. If we're heating something and we heat it on too high a setting, we can get some splattering that might occur and some of that reactant might pop out of our vessel. As soon as that happens, we're going to get less product, reduces our actual yield. Sometimes when we create a gas, some of the gas can get lost. We may not capture it all. Another reason. When we transfer from one vessel to another, from a flask to a beaker or whatever, if it's liquid or solid, any little bit that gets left behind in the first vessel, also going to reduce that actual yield. So those are just common ones that we have to account for, and that's why we have to be as precise as possible when we do it. The third one is impurities. So if we get something else in there, so obviously if you've got a dirty vessel, whether it's a petri dish or whether it's a crucible or whatever, if there's something else in there, then that's going to throw off our results as well. Another one is magnesium ribbon, which we dealt with, that little strip with a single displacement lab. If you leave that exposed to air, it will form a layer of oxide on it. It's no longer pure magnesium. So now when you have some magnesium oxide, that's going to change the amount you would have actually started with. You think you're starting with magnesium, but you're actually not. And that's going to change because some of it's already reacted with the air. Then because of that, if you were doing a lab where you want to see how much there was, you don't actually have as much magnesium as you thought. And then sometimes when we create a particular substance, that substance, another substance is being produced at the same time. So you've got competing reactions, one and the other. And when you have that happen, then obviously you're not going to produce as much as you had hoped. Okay, so again, percentage yield is actual yield over theoretical. So that was just a quick discussion on things that could throw off or change why your actual yield is lower than your theoretical yield. And some of them are unavoidable. The ones when we're as chemistry students in high school that you really have to watch is those ones you can control. Getting as much out, making sure your equipment is clean, doing all those things so you avoid any of those that you can. Okay, now the only thing here, it's one extra little calculation. Essentially, the calculation is exactly what we're doing. But I am going to do an example. It's one out of the textbook that I've included in the note. So our process is carbon dioxide and hydrogen to make methanol and water. Okay, so they say that you've got 20 grams of hydrogen, and they say that they give you a break in this question. They say that carbon dioxide is in excess. Well, if they tell you it's in excess, then you know we only work with the limiting reagents amount, which in this case would be the hydrogen. But if they hadn't said, if they said 20 grams of hydrogen and 37.4 grams of carbon dioxide, and that's all they said, then you would have to first determine which of those two is limiting. Find a number of moles of each, and then take number of moles of this one needs this many moles of the other one. Do you have that much? Yes or no. That determines the limiting reagent, and then you know to go from there. In this case, they've told us. So hydrogen's our limiting reagent right away. If I got 20 grams of this, that was how much was produced, 102 grams. So they told you this is what was produced in the question. So if they tell you this much is produced, that is the actual yield. So we have part of what we need. So we need the theoretical yield. Same thing we've done over and over and over again. Number of moles of hydrogen, 20 grams divided by 2.02, carry some extra digits. Ratio is 3 to 1. Take this number, divide it by 3. Got the number of moles of methanol. Find the mass, take the number of moles of methanol times the molar mass. 105.78, that's the theoretical yield. That's what we should get. Okay, but this is what we actually got. So we do our last calculation. Actual yield over theoretical yield gives you your times 100% gives you your percent yield, 96.4. So that's a pretty effective reaction right there. So the way that reaction was conducted is very effective because 96.4, if you got 96.4 in a test, you'd probably be pretty happy. So we wasted very little. We got almost all of what we wanted in that particular one. So we always want to have as high a percentage as possible. If you can get it to 100, even better. It's rare that it happens. If it's over 100, think about that in real life terms. If you get over 100%, so you get 102%, well, if you started with this and you should make this much if you use everything perfectly, and you got more, well, that can't just magically happen. We can't get more because that would violate the law of conservation of mass. So what that probably means is that magnesium example I just gave you, if you've got some magnesium oxide in there and it's heavier in terms of the molar mass and the amount that you've got, that is going to change your mass. So you should never get over 100%. You may get over 100%. They may ask you why in some of the questions. So just be aware of that. Okay, so I'll leave it there. Any questions, again, please send them in. People have been doing it. The next unit, so I'm going to put the Unit 3 test on the website today as well, along with a lab from Chapter 7. So again, I know it's a lot. Get through it as quickly as possible. The first part of Unit 4 isn't a ton of work. It's a lot of just talking about what solutions are, and hopefully you've talked about that before. So we'll go pretty quick through the first part of Chapter 8. I'd really like to get 8, 9, and 10 done in the next 3 weeks. That way we only have a week and a half to do the gas laws, and those are pretty simple. They're just straight formulas. Go to a word problem, pick out what you have, and then plug them in. But we'll talk more about that later. So lots of stuff going up on the site today. So hopefully you're caught up. And if you do have questions about the lab or the test, test will be tougher. You can do it twice, so do your best on that. And if you have any questions about these, please ask as well. Okay, guys, good luck on all those things, and I'll have another video up on Thursday. Bye.